Bismillahirrahmanirrahim. Assalamu alaikum viewers. You are watching YouTube and Facebook channels of Professor Dr. Rizwan Jamil Qureshi. Welcome to the lecture number 24 of Software Economics course. I was covering risk management strategies, proactive and reactive. Now in my today's lecture, I am covering the risk assessment, how to estimate the risk regarding the project. So we have risk exposure, that is probability multiplied by cost impact. The value of risk is always between 0.7 and 1. So we have first example, calculate the risk exposure for a project if 70% of the software components will be reused from the 60 selected components. Average code for each new component is 100 LOC at the cost of $14 per LOC and risk probability is 80%. So we have formula, risk exposure is equal to probability multiplied by cost impact, and cost to develop a component is cost per LOC multiplied by LOC. So let's have the solution. So software components reuse 70%. Total components needed to develop 60. Software components reuse 0.7 multiplied by 60, that is 42. How many new components we need to develop? 60 minus 42, that is 18. Cost per LOC for each new component is $14 per LOC and average code for each new component is 100 LOC. Cost to develop 18 new components is equal to 18 multiplied by 14 multiplied by 100, that is equal to $25200. So risk exposure is equal to probability multiplied by cost impact. Probability is 80%. So risk exposure is equal to 0.8 multiplied by 25200 is equal to $20160. That is our exercise 1. That means if these 14 new components failed, software company has to bear the loss of $20,160. Example number 2. Calculate the risk exposure if 70% of the components will be reused from the 80 selected components. Average code for each new component is 150 LOC at the cost of $15 per LOC. Risk probability is 75%. So we have formula, risk exposure is equal to probability multiplied by cost impact. So software components reuse 70%. So total components needed to develop 80. So how many new components? So 0.7 multiplied by 80, 56 are the reusable components, and new components 80 multiplied minus 56 is equal to 24. So average cost per LOC is $15. Average code for each new component is 150 LOC. So total cost to develop 24 components, new components is equal to 24 multiplied by 15 multiplied by 150, that is $54,000. Risk exposure probability is 0.75. multiplied by 54,000 is equal to $40,500. If 24 components failed, software company has to bear the loss of $40,500. That is the end of this chapter. Now I am starting the risk management chapter by Roger S. Pressman. According to Roger S. Pressman, what are project risks? How to define project risk? What can go wrong? What is the likelihood? What will be the damage? What we can do to reduce the damage? So probability is the likelihood. What are the main risks that can fail a project? What are their probabilities? How much they can damage to the project? And what corrective plan we can have to reduce the damage? That is the project risk. Then we have reactive risk management strategy. Project team reacts to the risk when they occur. Mitigation means risk avoidance. Plan for additional resources to anticipate to deal with the risk and as a firefighting strategy. Fix and failure, like when there is a bug, you try to fix it. So resources are found and applied when risk hits, strikes. Crisis management, you did not take corrective action when the risk initially reported. For example, budget. For example, schedule risks. The budget risk, initially the project manager or the risk manager did not take corrective action to bridge the gap between planned budget and the actual budget, planned schedule and the actual schedule. And at the later stages, now there is crisis management. failure of the project is going to be happen and project is in danger. So now you need to do crisis management, the reactive risk management strategy to deal with budget risk or schedule risk because corrective actions were not taken at the appropriate time. Then you have proactive risk management. Formal risk analysis is performed. Organization corrects the root causes of the risk. What are the root causes of that risk? You have TQM concept and statistical software quality assurance. So question arises, what is the TQM? TQM stands for total quality management. So what is total quality management? Total quality management concept was started in 1980s and become popular in 1990s. So we have ISO and we have other standards. What is total? Quality involves everyone and all activities in the company. Quality, what is quality? Conforms to the requirement that software or the product must meet the requirements of the customer. Management means planning, monitoring and control. The quality can and must be managed. Now we can define TQM. We know total, we know quality, we know management. A process for managing quality, a philosophy of continuous improvement in everything of the organization, in terms of processes, in terms of activities, in terms of teams. So we have TQM principles. Quality can and must be managed. Everyone has a customer and is a supplier. Processes, not the people, are the problem. Every employee is responsible for quality. Problems must be prevented, not just fixed. Quality must be measured. Quality improvement must be continuous. Life cycle cost, not front-end cost. Management must be involved and lead the team. Plan and organize for quality improvement. So these are the total quality management principles. Now you have software process improvement, software quality and process improvement through the ISO and the Software Engineering Institute Capability Maturity Model, which are the quality standards for software. So software development process, how we define that it's a standard methodology used in our organization to analyze, design and implement the software system. What are the goals of a software process? That the product should have, or software should have of high quality, economical, on-time delivery, within budget, within schedule, and political, technological or market needs should be met. And we have different ISO, IEEE standards are there. Ideal process model must be predictable, means consistency in cost and schedule estimations. Quality and functional requirements should be met, so it should meet the quality and functionality. Defined standardization, independent of individuals, it should be repeatable. You can customize it, you can practice it from project to project, system to system, and it should be statistically controlled. Measurement, insight, optimization, continuously improve, customize. So ISO are having different standards. It's a family of standards. Then we have General Total Quality Management. Then you have Software Engineering Institute, software specific, and we have ISO 15504, and we have other standards like Trillium, Bootstrap is there. ISO is a family of standards. Objective is customer focus, leadership, involvement of people, process approach, system approach, continuous improvement, factual approach to decision making. So facts, data should be there, mutually beneficial supplier relationships. So ISO, as I said, it's a family of standards. ISO 9001, 2, 3, 4 onwards. ISO 9001 version 2000 is applicable for software. ISO is introduced as for generic. We have two types of companies. We have product-oriented companies and we have service-oriented companies. And ISO is applicable for both. Like for example, we have Toyota company or Honda company or any car manufacturer, we have products. Like in Saudi Arabia, Latif Jameel. Latif Jameel has a showrooms to sell the cars, so it's their products. And Latif Jameel also has service centers where you can go and you can repair your car, maintain your car, you can have the service. STC, or in Pakistan we have PTCL. They have products like they have Wi-Fi devices, they have broadband, and then they have services. So similarly, Nestle, they have products and they have customer care centers are there. Unilever, they have products, they have customer care centers. So we have products and we have service oriented companies are there, product oriented and service oriented companies are there. ISO is applicable for both, but specifically for software, we have ISO 9001 version 2000, which is applicable for software companies. So ISO has scope, reference, definition, we have framework, we have management responsibility, we have quality, we have internal quality audits, we have supporting activities, and so on. CMM, capability maturity model, which is another quality standard, it has a prerequisite. So if you want to start CMM, capability maturity model certification, you need to achieve ISO. The problem with ISO that in every country there are local bodies, like in Pakistan we have Moody, and even the second world, third world countries. So in Saudi Arabia there are local people. So in Pakistan, I remember the case after my degree, I went to factory for a job, and the product they manufacture sui gas meters. Like electricity meters, we have sui gas meters. So aluminium is used to manufacture the sui gas meters. Aluminium has a melting point 600 degrees centigrade. So the owner, because it was a private factory, the owner start purchasing the scrap from the market, and then he melted scrap. There are some metals which have low melting point. So when you heat them to convert from solid to liquid, so they fuse at a certain stage. So when you pour that liquid metal into die to have the shape of meter, the low melting point metals fuse, and because of that there are small holes, pores are there. And then like car tire or motorbike tire or bicycle tire, you have puncture shop, and that guy, the puncture shop guy, will pass hawa, will pass air from the tire, punctured tire, and then he put that tire or tube in the water, and the bubbles will start coming out, and then he use color pencil to mark that puncture place and use some glue or some material to fill the puncture. The same philosophy, same principle that factory was doing. So when there are some meters which have defects, they pass air and then use color pencils to mark them, and after that they used super glue or Alfie to fill the holes, and then they supply. I did job there for 3 days. The first day, at the end of the day, in the evening, owner came to the factory and asked me what was the production. Their production was almost 110 meters per day. And out of 110, 90 meters were defective. Only 20 were correct. They don't have any fault. So he asked me, and when I told him there were 90 plus was defective and only few 15 to 20 are without having any fault. He said in the ISO documentation you write that 90 plus are okay and only 15 20 have defects, have faults, have pores. But I was not happy. I was not ready to do that. The second day, again, almost the same result. He came in the evening and he asked me, did you do the documentation yesterday? I said, no. He said, okay, do it for yesterday and do it for today, and do as I asked you to write that 90% plus are okay and only few have the defects. The third day at the lunch time, I left the factory and I quit the job. So after a few months, I passed by the factory and I saw in the large capital characters of aluminium that ISO 9000 certified company. So because of the local people, they are influenced by using the reference or by having the bribe. So you got the certification. So because of that, in America, the Software Engineering Institute is there, which is and controlling body to have the CMM. They don't allow any local body to deal with the certification. So it's totally controlled by Software Engineering Institute, which is owned by Carnegie Mellon University. That's some facts about the ISO and then why it's a prerequisite for the CMM. So in 1982, American Department of Defense have a problem to review the software. So then Software Engineering Institute was established in Carnegie Mellon University in 1984, and objective was to improve the processes of Department of Defense as well as the software industry. So in 1991, capability maturity model was introduced. So capability maturity model is specifically for software, whereas ISO is generic. It can be applied for hardware, it can be applied for the system, it can be applied for the organization in generic. So total quality management is in general and CMM is specifically dealing with the software. Thank you very much. Jazakallah khair. May Allah bless you. Assalamu alaikum.